All right, welcome. Just want to offer you guys a quick walkthrough on the 514 writing equations for quadratic functions. Our essential question today is, how can we work backwards? What if we already know the x-intercepts? Can we find the equation that goes with it? All right, so 538 you're going to work on with your team parts A, B, and C. I'm going to jump down here to part D. I want you to consider this function, y equals 2 times x plus 3 times x minus 2. It's the factored form for this function. What are the zeros? Well, we learned in the last lesson that the zeros we can find by setting each factor, x plus 3 equal to 0 or x minus 2 equal to 0. And so if we think about this, what value of x is going to make this equal to 0? Well, it's going to be negative 3. And what value of x here makes this? That's going to be positive 2. Here's like the main point for this lesson. If we knew the zeros, like let's say we know negative 3 and 2, could we work backwards to find the factors? So let's say all we know are the zeros are negative 3 and 2. We don't know this function. We don't know this function. What could the function look like? Well, if x equals negative 3, and I worked backwards to set this equal to 0, I would have to add 3 to both sides, and so I get x plus 3 equals 0. This must be one of my factors. Okay, and if I do the same thing with my other x-intercept, 2, well, then the factor that goes with this must be x minus 2. Why does it have to be x minus 2? Because if I plug in 2, that's what makes this equal to 0. And so I have these two factors, and so my equation might be x plus 3 times x minus 2 because they would share the same zeros. So let's take a look. What's the same and what's different? Well, what's the same is these factors. X plus 3, x minus 2, x minus 2. What's different though, notice our original has this 2 out in front and we don't really have that 2. All right, we call this our A value. It's like our common factor. And so using this process will tell us the factors, but it won't necessarily tell us the common factor or the A value out front, okay? All right, let's take a look at a table. All right, use the zeros from the table to help write a possible function. And I want to remind you that zeros are another word for x-intercepts. And for your x-intercepts, we know that we have to set y equal to 0. Okay, so when we look at our table, where are the x-intercepts? Well, if the x-intercepts take place when y is 0, then I should be able to find my x-intercepts. Okay, so I know my zeros are at negative 3 and at 2. So what factor goes with negative 3? X plus 3. And for the 2, it's x minus 2. And so I put these together to write my function, x plus 3, x minus 2. One more time, why are these the factors? Plug in negative 3. Negative 3 plus 3 is 0. Plug in 2. 2 minus 2 is 0. Okay, I get this function. Does this function work? Well, let's pick a sample value to plug in. Let's plug in 0. What's 0 plus 3? Okay, so if I go 0 plus 3 times 0 minus 2, I get 3 times negative 2, and 3 times negative 2 is 6. Yeah, it checks out. All right, and so I know in this case, when I have my table and a point that I can test, I know my A value is 1 because everything worked out. I don't need a multiplier here. We could also rewrite this function if we distribute as x squared minus 2x plus 3x minus 6. So it would look like this, x squared plus x minus 6. All right, I want you to take a look at the next two, A, B, and then on 540 you're going to compare the table there to the table here in A. All right, good luck.